So let's start this webinar. So first of all, my name is Ankit Negi. I'm a software engineer at Optimizory. And in this webinar, we are going to discuss about the introduction to LLMs. We are not going into technicality behind it. We are just looking at the introduction to LLMs. So let's start the webinar. So the topics that we are going to cover in this session, they are, first of all, we are going to discuss what are LLMs and why are they so important and how do they work and typical phases at the time of LLM training. What are the typical phases of LLM when they are trained and how does the prediction happens? And then we are going to discuss some applications of LLMs, then challenges and limitations which are faced in current version of LLM, and then finally we will discuss future of LLM, and then we will look at a small project that I made in LLM. Then now let's start this webinar. So first of all, with the most basic topic of this webinar is what are LLMs. So LLMs are basically very advanced AI models, and they're developed on deep learning. Deep. So here I've used two very important keywords here. First one is AI models, and the second one is deep learning. So first, let's discuss what is deep learning. Deep learning is a very is a sub branch of machine learning. It's a very vast topic in itself, and you can leave your comment on that. If you want a separate session on deep learning as well, we can arrange it as well. And deep learning is basically it deals with mimicking the power of human brain. All the capabilities a human brain has, it mimics it. What are the powers of human brain? We can recognize patterns, we can make decisions, and we can recognize images. All these powers for a machine to learn, we develop deep learning. And if you logically think all the features that LLM has, we need a power of human brain to make those features. So that is why we make AI models on deep learning. And the second keyword that I discussed here was AI models. So if you have worked on programming, so you must have worked on functions. So AI models and functions are similar. What functions does? A function takes parameters and produces an output. That is same behavior of a model. Model also takes parameters and produces an output, but there is one key difference between a model and a function, and that is a model is clean. We Because we have written the function, a function is clean. We have written the function, so we know what is happening inside. But on the other hand, a model is much complex. It is mathematically complex, and it is hard to imagine what is happening inside of a model. We cannot imagine because it has multi-dimensional data inside of it, so we cannot imagine what is happening inside of a model. So a model works similar to function, but it is more complex. A model takes parameters and produces an output. So LLM is a AI model which is developed on deep learning. And LLM is trained on massive textual data. LLM basically works on textual data. A user gives a text prompt and LLM produces a text response. So it works on textual data only. And why are they so important? Like, why are they so talked about right now in this current era? Why LLMs are so talked about? So first of all, we have so many AI models. Like we have LLM, we have other AI models as well, like image generation model. We have animation models. We have video generation models. So why are not these models as much as talked about as LLMs? So first of all, if we think logically, if we take example of any image generation model, there's so many image generation model available. People logically think that image generation model working with image generation model is much complex than working with LLMs. First of all, they are both complex in their own ways, but working with LLMs is actually much complex. Why? Because if we think what is an image, if we consider an image is nothing but a collection of small pixels, a pixels that our screen has. So an image is just a collection of pixels, and a pixel is just a number between 0 to 255. It is a number. So an image at the end, it is a collection of numbers. As we may know that our machine can easily work with numbers. So our machine can easily work with images because it is just an collection of numbers. But on the other hand, LLM works with textual data, and texts are not numbers. So our most important task is to convert the text into numbers, and we do it by the process called tokenization. We convert our text into collection of numbers, and that collection of numbers is understood by our model. And this tokenization process should be done in such a way that encoding and decoding both are possible. That we had a sentence, and then we converted that sentence into a collection of tokens, collection of numbers. Now that collection of numbers should be easily decodable to our original sentence without rearrangement of words. We should get proper arrangement of words that we feed it to our model. So this is tokenization part. So, and one more reason why LMs are particularly most talked about is that because we have huge amount of textual data available. Yes, we have image data available as well, but we have every kind of data available in the text format. That is one more reason why LLMs particularly are most talked about. So, what are LLMs? They are advanced AI models which works on textual data. They accept text, and they, in response, they also provide text. So now let's learn what how do they work. So there is this transformer architecture which works behind LLMs. So the current form of LLM, there we should be thankful to this transformer architecture. Just because of this, today's LLM is possible. So what is architecture? Let's understand. An architecture is a workflow. It is basically a workflow of anything. Workflow means first this will happen, and then this process will happen, and then this, till the end. It is all assigned, it is all fixed, that these are the process that which will happen inside of this architecture. So this is architecture, and this image here, this is transform architecture which is working behind our LLM. So current LLM, which if we talk about chat gpt and other LLM applications, transform architecture is standing behind them, and they are working on this transformer architecture. And transformer architecture is sole backbone of current form of LLM. The research paper of transformer was published in 2017, and there are so many things which happen inside of this architecture. And should I say that everything which LLM does happens inside of this architecture. We provide our prompt, and it gives us output. Everything is happening inside of this project, inside of this architecture, be it encoding or be it tokenization or predictions of response or decoding of response. Everything is happening inside of this architecture. But there is this one very important mechanism inside of this architecture which is called as self attention. So self attention is a mechanism inside of our transformer architecture, and it helps us to find the most important piece of information in our data, or should I say in our sentence. So if I take example, if I consider sentence that I want to purchase a new phone in this weekend. So this is my sentence. If I have feeded this sentence to my model, so what this self attention mechanism will do, it will provide it will assign a score to each word of my sentence, and higher the score, higher its importance, higher its contribution to the context of my sentence. So in my sentence that I want to purchase phone this weekend. So purchase, phone, and weekend. These three words will get highest score, because using these three words I can understand whole context of my sentence. So self attention mechanism helps us to find the context of my sentence, that what my sentence actually wants to say. Words like I, am, the, a, and they do not contribute to context of any sentence. So these words will get low score, and everything is happening inside of this architecture. So this architecture is bit advanced topic. So for this introduction part, this information is enough that everything is happening inside of this architecture, and there is this self attention mechanism which helps us to find the context of our sentence. So let's proceed. So the training of LLM typically goes through two phases. There are two phases of LLM training. The first one is pre-training of any LLM, and the second one is fine-tuning. So these are the two phases. So what is pre-training? Pre-training is a phase where our model learn the basic things. basic things like how to understand text, how to read it, how to generate a response, how to generate a response in nice way, means not being rude to end user. So we use tech data from internet, data from Wikipedia we use to give basic knowledge to our model. And after pre-training, the pre-trained model becomes the base model for fine-tuning. We fine-tune our pre-trained model. So what is fine-tuning? Fine-tuning is done when pre-trained model is ready, and then we train our pre-trained model on specific data, specific use cases. We want our model to be prepared for specific use cases. For example, if I own a company and I want my if I and I want my customers to not directly communicate to call center, I want an AI agent, an AI chatbot, so that my customers can communicate to my AI bot instead of calling in customer care for small queries. So what I will do, I will take a pre-trained model which already knows English language, and then I will fine-tune that pre-trained model on my company's data. After fine-tuning, my pre-trained model will be fine-tuned on company's data, and it will do the specific task that I want it to do. It will handle customers, and it will be better than customer care because it will be able to handle multiple customers at the same time. It will give faster replies. So these are two phases of LLM. First one is pre-training, where the base model is prepared, where when it knows how to read and how to process a response, and then fine-tuning of a model where it is trained on specific tasks. So these are the two phases of LLM training. And then how it predicts. So even the prediction happens inside of the transformer architecture. So let us assume a prompt. A prompt is the quick brown fox, and this is incomplete prompt. Okay, there are more words in this, but I am only giving this prompt, these four words to my LLM. So this is a very famous sentence in English language. The full sentence is that the quick brown fox jumped over the lazy dog. Why is it unique? Because it has every single letter of English alphabet, and I want my model to predict this whole sentence. Now, I expect my model that it has been trained on this sentence. I expect my model because this is a very famous model. So I want my model to complete the sentence for me. So first of all, the tokenization part, as I discussed, that computer cannot understand this. It will be able to understand this, and now my computer will be able to understand this collection of numbers, which is known as tokenized form of sentence. So the prediction process will happen. It will search on its massive data to find something relevant, and it will find. And at the end, it has huge dictionary of every single word in English alphabet, and it will assign probability to each token. You see, these words, they are also known as token because we convert each word into a token. So probability will be assigned to each word. As you can see, the word which is supposed to come next is jump. So it will give 75% chances that jump will be the next word. And played also has 10% chances. But our model will, in the voting process, after this, the voting process happens, and the word with the highest probability gets chosen. And when the voting process is done, my model checks if the sentence is completed or not. If the sentence is completed, it generates an end token. And when the end token is generated, my model stops the execution and serves full response to user. If it is not generated, then the process is repeated again, and it then searches for the next word, next token. So the word jumped will be assigned here, and then the quick brown fox jumped will be our new prompt, and then the next word will be predicted. So just like it will predict next word. So LLM does not predict whole sentence. It just predicts the next word, the next token. So this is how it works. So so this is how prediction process happens. It also happens inside of our transformer architecture. Now let's understand few applications of LLMs. So uh, these tasks are already possible in ChatGPT. First of all, the text generation. When user provides a simple and small text For example, content generation. We can create blogs in ChatGPT. So text generation is one example. The other example, as I already talked about, chatbots. A company can create their own chatbot so that customers will not have to call to customer cares for even small queries. They will directly call. They will directly communicate to AI bots, and AI bots are actually more efficient because they will give replies in real time, faster replies, and they can handle multiple customers at same time, and their maintenance cost will be lower than managing a call center. Question answering, similar to chatbots, and then sentimental analysis, one of the most highly used and most important use case of LLM. What is sentimental analysis? We find sentiment behind any sentence using this feature, using this use case. Let's take an example. I own a restaurant chain and I have my Google reviews. So what I want to filter out positive reviews and I want to trash the negative reviews. And it is possible to filter out positive reviews using sentimental analysis. What does it do? It has dictionary of all the good and bad words, and using the power of NLP deep learning, it will find that if a sentence is good or not. So it finds sentiment analysis used to find the sentiment behind the data, behind text. And then finally, not finally, there are many applications of LLMs, but these few applications are mostly used. Then code assistance, as you know, you can use ChatGPT to find your code, to take help in code. And in VS Code, you can find multiple extensions to help you in code assistance, which recommend you what should be the next code, and all the possible scenarios you should consider while writing your code. Now, few challenges and limitations of current version of LLM. Challenges which are faced by current version of LLMs. First of all, the biasness. Biasness means, what is meaning of biasness? Biasness means being one-sided. Let's take example that we have a coin, and coin has heads or tails on both the sides of it. Then the coin will be biased. If coin has heads on the both of its sides, then tail will never appear. So coin is biased towards the head. It is unfair. So biasness is a big problem when data has biasness. For example, it has racial information in it. It has inappropriate information which can be bad for kids, or it promotes terrorism because we are extracting data from the internet. Internet can have any type of data, and not all every data in the internet is true. We can have false data in the internet as well, and our model may get trained on that false data as well. So we need to take care of these scenarios, that our model should not be racial. It should not promote terrorism or racism. It should not promote false information. And one more example of biasness is that if in my data I have piece of information repeated many times. If a piece of information is repeated many times, our model may be forced to learn that that piece of information is important to us. But it may or may not be. That piece of information may or may not be important. But just because that piece of information is repeated many times, our model may think that it is important. So we should be handling biasness at the time of pre-processing of data. Before the training part, we should handle such cases. And then the next challenge or limitation in LLM is hallucination. Hallucination actually one of the big problem of current LLMs. What is it? You can actually find hallucination in ChatGPT as well. When you ask model something and model has no data to back that information, it will generate its own answer. Like, if you ask something to a model, and if it does not know the answer, it will generate its own answer. It will hallucinate by itself. So that is called hallucination. And this is actually major problem in LLMs, that they tend to create their own answers when they don't have data available to back up the user's question. Then finally, the not finally, we have computational cost. It is very expensive to run an LLM machine, LLM server. Even the management cost is very expensive. Even if you want to make a small production quality LLM, you need dedicated GPU for it. You cannot make LLM in CPU. And environmental impact, the training and maintenance of LLMs significantly contributes to carbon emissions, and it is one of the major limitations of current LLM. And uh, one more challenge is that it does not have internet access, which means current form of LLM has no internet access. Anything which is happening in this world right now, our LLM does not know it because it needs to be trained on data. So it has static knowledge. So to keep my LLM up to date, I have to keep it updating on updated data. So this is one more challenge of LLM. Now let's understand. There are more challenges, but these challenges are most critical in current form of LLM. Now let's see the future trends in LLM, which means what can we expect from LLMs in future. So first of all, multimodal models. So as I told you that LLM only works in textual data, but in future we may expect it. In future, not in future, we already have models. ChatGPT accepts images and videos as input. So companies are actually investing heavily on such developments, and we already have multimodal models which accepts images and videos as input. And in future we may get less energy intensive models which are faster to train, does not require heavy computational power, and they may work on real time data. They may have internet access, and they may become more intelligent. They will become more intelligent because AI is continuously progressing. If you look 2 years back and now, AI has progressed a lot. So we will expect our LLM will get more intelligent. So these, so we discussed so far we discussed what is LLM, why are they so important, how do they work, what is the transformer architecture which is backing this LLM. Then we discussed the typical phases of LLM, that pre-training and fine-tuning. How do we create base model in pre-training, and then we do fine-tuning of pre-trained model, and then we discussed how the prediction process happens, which happens inside of this transform architecture. Then we discussed few applications of it, some challenges and limitations of LLMs, and then we discussed future trends in LLMs. Now let's see a small project which I created in LLM. So we are not going to see the technical part of it. We are not going to look at the coding part of it, because this is just introduction part. So this model, this is the AI model, and this is my pre-trained model which I discussed here. Here, the model which has basic understanding. So this is my pre-trained model. It knows English language, and this is the data. These PDF files, it has my data which I want to fine tune to this pre-trained model. So I'm doing this fine tuning on this pre-trained model here. Now this fine tuning is happening at the backend. I want to show you this custom prompt template. So I have given this custom prompt template, and I will add user's query on top of this template. So here I'm saying that use this following piece of information, this piece of information, the data in which it will get trained, to answer user's query. If you do not know the answer, just say you don't know. Don't try to make up the answer. I'm trying to tackle the hallucination part. I'm telling my model that if you do not know the answer, just say that you don't know. Don't try to make up the answer. So here, if you look closely, I just gave command to my LLM in English language. I did not use any coding. I just gave command to this model in English language, and it was able to understand it because it was pre-trained. So selection of a pre-trained model is very important. Your pre-trained model should be good enough. Now this coding, we should ignore this coding part, and I'm using this chainlet library which provides UI, chat GPT type UI. So now let's see the output of it. So here is my chatbot. I asked what is React.js and what are its features. So here is my response. This is my response. You can ignore this part, but this is my response. It's a small response, but for the development purpose, I think this is good enough. If we if we have GPU, dedicated GPUs or powerful system, we can train it better than this. Now it is giving me accurate answer. It is a small answer, but it is an accurate answer. It is not false answer. And it is also telling me that which PDF file did it use to get the answer. Then I asked it what is DBMS. It stated me the definition of it, the full form of it. So it is working fine. And as you can see, we are able to chat to our data. So in this pre-trained model, it did not know this data. I trained my model on this data, and my model is now able to answer on this data. So how amazing is that? So this is LLM. We are done with our webinar. So thank you for attending this webinar. And if you have any question, you can ask in comment section. We'll wait for a few minutes. Okay, I think there are no questions. So thank you for attending this session. I hope you are leaving with some knowledge. Thank you for attending this session.